Hello again, Steve here with another Astronomy Daily. It's the 14th of April 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right, we're back again, and while Hallie downloads into the Australia studio, I'll fill you in on today's selection. Hallie found a couple of interesting stories, a great one for film buffs. Did you know that 40 years ago they made an IMAX film in space? Well, I didn't know that, so we're going to look into it. And some disappointing but not unexpected news that the Trump administration may be planning to slash funding at NASA. I know we touched on this a few weeks ago, but I'm sure every skywatcher, space hound and orbit jockey is saddened at the prospect, but we'll have to wait it out and see what happens.
I'm here now.
Oh, great. Good to see you, Hallie.
I was busy collating with Anna for the weekly podcast sessions.
The Easter break's coming up, so she's got it all in her hands.
She's got it all sorted, but I think she likes the company.
Oh, I'm not surprised. Say hi for me next time you're in the Astronomy Daily virtual studio, won't you?
Will do. What did I miss?
I was just doing the story rundown for today. I got to NASA's announcement of a seat barter agreement with Roscosmos, and the last story...
The last story?
Yes, where is it?
Oh, that's the one about lunar concrete. Weird stuff. Right up your alley, that one.
Ah, yes, no argument there. I am a moon fan.
A lunatic.
Ah, well, if the shoe fits.
It fits. You do love stories about the moon.
Can't help it. Guilty as charged. Anyway, so let's get into it, Hallie. Go hit that go button.
Okies. The dream is still alive, the first IMAX film shot in space at 40 years. 4 decades later, astronaut Marcia Ivins and cinematographer James Nahouse reveal stories from the making of the giant screen movie. James Nahouse had one more thing to share. From inside a tote bag, he pulled out a chrome frame displaying 11 strips of tape, each of which had printed text and handwritten notes. These were labels removed from film cans, the award-winning cinematographer explained. But not just from any film, these were the 41-year-old labels from the third space shuttle mission to carry an IMAX camera into Earth orbit. The rolls were used in the making of the first movie to include scenes shot in space, as first released 4 decades ago this June. So this is from 9 rolls of film on STS-41G. This is all astronaut handwriting on this, said Nahouse at the end of a panel discussion celebrating the upcoming 40th anniversary of The Dream is Alive at the National Air and Space Museum's Stephen F. Udvar-Hazy Center in Northern Virginia on Wednesday, April 9th. The 37-minute documentary about NASA's space shuttle program includes footage shot by the astronauts showing how they live and work in orbit, including the capture and repair of the Solar Max satellite and deployment of an experimental solar array. Veteran journalist and TV news anchor Walter Cronkite narrated the film. "I've hung on to this for about 40 years, said Nahouse, referring back to the framed tape strips. "I'm giving it to the Smithsonian, hopefully to go with the IMAX camera that they already have." The National Air and Space Museum's connection to The Dream is Alive extends beyond the related artifacts in the National Collection. The original idea for shooting a giant screen film in space began with a conversation between the museum's first director, an Apollo 11 astronaut, and the co-inventor of the IMAX film format, a Canadian filmmaker. One of the things about the film that most people probably don't know is that it's a direct result of a suggestion to Graham Ferguson from Michael Collins after the National Air and Space Museum opened in 1976. Nahouse told CollectSpace.com in an interview prior to the panel discussion, which was organized by the National Air and Space Society for its members. Collins suggested to Graham to see about flying an IMAX camera on board the space shuttle. And Graham said, "That sounds like a really great idea. What's a space shuttle?" Nahouse said with a laugh as he imitated Ferguson's Canadian accent. It was also Collins' idea for the museum to have an IMAX theater, and it became only the 6th such theater to open in the United States. From there, it led to the Smithsonian becoming directly involved in the production of The Dream is Alive, as well as the 2 shot-in-space IMAX movies that followed it, Blue Planet in 1990 and Destiny in Space in 1994. Collins saw the effect that IMAX films had on our visitors, and he realized that a film made in space would amplify the storytelling about astronaut life there, said the panel's moderator, Jennifer Levasseur, who is a curator in the Space History Division of the National Air and Space Museum, oversees the museum's collection of cameras used in space. He and others lobbied for such a film, and with Lockheed financing it, NASA couldn't resist. These films weren't developed as promotional materials for NASA, but really as a means for everyone involved in the space program to communicate, educate and inspire, said Levasseur. The Dream is Alive was described as the closest that the public could come to experiencing spaceflight without leaving the planet. Those of us who have filmed IMAX in space and who have flown in space have always said that, and it's not just to repeat the soundbite, it's actually true, said Marcia Ivins, a former NASA astronaut who flew into space 5 times and holds the record for taking part in the most IMAX space films, at 3, and advised on the production of others. Selected as an astronaut in 1984, Ivins was filmed for The Dream is Alive during her and her classmates' water survival training at Homestead Air Force Base, today, Air Reserve Base, in Florida, but her scenes did not make it into the movie. So they tossed me off the back of a boat, and I'm trying not to drown, and while I'm trying not to drown and remember all the things they told me to do to not drown, here comes this boat right alongside with the film crew, said Ivins. And while I was not drowning, I did have the presence of mind to express myself with a hand gesture. And at the end of it, associate producer, Phyllis Ferguson comes to me and says, "We really wanted to put you in the movie, but everything we shot of you was either pathetic or obscene, and a great relationship with IMAX was born that lasted to this day," Ivins said with a smile. Wednesday's event concluded with a rare screening of The Dream is Alive. With the move to digital, high-resolution projectors, the 40-year-old film really needs to be rescanned, a project that Nahouse is now championing. The parts of the space flown film that made it into what you see on screen are conserved in climate-controlled storage in Los Angeles, as are all of our original space negatives, said Nahouse. In theory, you could go back and pull any of that IMAX footage, scan it into whatever resolution your digital system is today and have a pristine digital version of the film. A lot of the films that are extremely important, such as the space films, are being scanned. I know, The Dream is Alive is, as that's something I'm heading up on the committee to work on that for the giant screen film industry, he said.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Multiple space agencies are looking to the moon as a future destination for exploration and development. This will include the creation of a permanent infrastructure that will enable regular crewed missions and possibly future settlers. It's also hoped that this infrastructure will lead to regular missions to Mars, which could also lead to regular human presence there. These plans require robust and innovative construction materials that can endure the harsh lunar and Martian conditions. And we all know that the Martian soil is toxic as well as radioactive. So is the regolith on the moon as well. These include extreme temperature variations, near vacuum of space, radiation and micrometeorite impacts. To meet these requirements, a team of researchers from the University of Texas at Dallas proposes using self-healing concrete, also known as bioconcrete. This material, inspired by biological processes, consists of bricks fabricated with the help of bacteria that regenerate themselves over time. Combined with lunar regolith, self-healing concrete could enable long-duration research stations and habitats on the lunar surface. The study was led by Shruti Panda and Jacob T. Penner, a neuroscience researcher and biomedical engineer senior, respectively, at UT Dallas. And they were joined by a team of UT Dallas researchers, including Dr. Kelly Palmer and the Cecil H. and Ida Green Chair in Systems Biology Science in the Department of Biological Sciences. As they explain in their paper, bioconcrete utilizes a mold biomineralization and calcium carbonate crystal formation to create a durable and self-healing product. NASA and various research institutes are investigating mycelium fiber for applications in space exploration. This includes using mycelium to build tough, heat-resistant and environmentally friendly satellites that would reduce the threat of space debris and the environmental risks associated with satellites burning up in Earth's atmosphere. In addition, NASA has been researching mycelium as a potential alternative to building materials like concrete for building habitats on the moon and Mars. As Panda and Penner said in a statement, bioconcrete also presents many advantages for lunar construction. They say, considering the heightened durability and strength of bioconcrete, along with its decreased recovery time, the application of such a structure to the harsh conditions of the moon may allow for enhanced longevity of lunar structures. These harsh conditions include extreme temperature variations, elevated radiation, the vacuum of space, and of course, micrometeoroid impacts. There's also the lunar day and night cycle in the polar regions, which consists of 14 days of continuous light, followed by 14 days of darkness. In a previous article, one of the concepts submitted to the 2025 LPSC proposed combining mycelium fibre with inflatable structures to create durable structures on the moon. For their study, Panda and Pena elevated bioconcrete fashioned from bacterial lunar soil simulant. Previous studies have focused on using lunar regolith as an in situ material to build structures on the lunar surface. However, adding specific bacteria to withstand the lunar environment could strengthen bricks fashioned from lunar regolith and prevent degradation. This is consistent with Section 12, Materials, Structures, Mechanical Systems and Manufacturing of the 2024 NASA Technology Taxonomy Report. As they describe in their paper, their tests of relative strength of lunar bioconcrete consists of 3 steps: finding the right bacteria and creating spores, creating bricks, encasing them, and in situ testing. The team considered 13 types of bacteria derived from a reef system, which were rendered into pellet form, as Panda and Pena explain. 9 bacterial strains pre-screened by genetic sequencing to be from spore-forming genera, and 4 seawater consortia were cultured in artificial reef media using instant ocean reef with added nutrients and a calcium source. The bacterial strain Bacillus toyanensis was chosen due to its ability to sporulate and produce bioconcrete, as well as its high tolerance in extreme environments. After selecting the strain of bacteria, culturing and forming it into pellets, these cultures were then aspirated, washed, dried, and then eventually formed into bricks, using a combination of resin, a curing agent, and pellets of the bacteria with lunar soil simulant, nutrients, yeast extract, and calcium lactate. While this may all sound like a recipe from a science fiction movie, the results indicated that bioconcrete bricks were more effective at self-healing and suited for lunar conditions. Looking ahead, Panda and Pena plan to conduct tests consisting of traditional concrete control group and 3 experimental groups to isolate any additional factors, and these will consist of traditional concrete with bacteria, concrete with lunar soil simulant and no bacteria, and lunar soil simulant and bacteria. As the researchers emphasised, the tests will include an analysis of B. toyanensis' ability to spore during the concrete's manufacturing process, its compression strength, and its ability to withstand radiation. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Reports circulating about the White House's proposed NASA budget for the 2026 fiscal year suggest the agency's funding could be slashed by nearly half. As reported by Ars Technica, so-called passback documents given to the agency on Thursday, April 10, outline these Trump administration budget plans. Besides an almost 50% cut across the board for NASA science programs, they propose a two-thirds cut to astrophysics, down to $487 million, a greater than two-thirds cut to heliophysics, down to $455 million, a greater than 50% cut to earth science, down to $1.033 billion, and a 30% cut to planetary science, down to $1.929 billion. We would see, in this case, the majority of active science missions and in-development science missions completely wiped out, Casey Dreyer, chief of space policy at the Planetary Society, said. I have this image in my head of a perfectly functioning spacecraft designed to increase our understanding of the cosmos in which we reside turned off and left to tumble
Astronomy
aimlessly
Daily
in the black.
with Steve
That's where we would
and
leave
Hallie.
ourselves.
Space,
It's
space
symbolically
science,
grotesque.
and astronomy.
According to the document, the proposed budget would continue to support science missions such as the Hubble Space Telescope and James Webb Space Telescope, but assumes no funding is provided for other telescopes. This means it'd likely get rid of the Nancy Grace Roman Space Telescope, a spacecraft that's already assembled and undergoing testing to launch as early as next fall, Dreyer says. That has been the poster child for a mission that has remained on budget and on track with the one hiccup around COVID, which isn't the mission's fault, he said. We've invested nearly $4 billion in building it to this point, 20 years of effort to build it. The passback documents also suggest closing down the entirety of Goddard Space Flight Center in Maryland, meaning the approximately 10,000 workers at that center would probably be laid off in tandem. It's like a nuclear bomb going off. It's NASA's largest center, Dreyer said. Though these passback documents aren't a full confirmation that this budget will be finalized, Dreyer says it's the last train out of the station before we get to that point, and in his expert opinion, Dreyer believes this proposal certainly could move through to the end. This is especially because of the kinds of changes, including major layoffs and project cancellations, that have been implemented at other government organizations by request of the Trump administration. It is consistent with their willingness to impose some very profound and dramatic change, he said. For instance, the National Oceanic and Atmospheric Administration, NOAA, laid off over 800 workers this year, and there are rumors of more cuts to come. In fact, an internal budget document seen by Science magazine suggests the Trump administration wishes to cut nearly all of NOAA's climate research endeavors. According to Science's report, the document indicates the White House intends to ask Congress to eliminate NOAA's climate research centers and cut hundreds more federal and academic climate scientists. This would end basically every project we support other than hurricane and atmospheric river reconnaissance, coastal mapping, and snow survey, all of which are funded by either the National Weather Service or National Geodetic Survey. All marine mammal, atmospheric science, and climate projects would end, one NOAA worker who requested anonymity said in a statement. This is one of the reasons why you have a public sector, to do things that aren't immediately profitable, but important and beneficial to the nation, Dreyer said. There's no private mission ready to go to Mars or Jupiter. These are fundamental capabilities of a public sector space agency serving a unique need. We've seen wealthy individuals start to travel in space themselves and invest in rockets and infrastructure, he added. But something we have not seen by anyone, and nor has anyone even shown much interest in, is to build these types of science missions. For instance, Dreyer emphasizes how difficult it would be to finance another Voyager mission, the NASA endeavor that sent twin spacecraft to explore the territory beyond our solar system in 1977. Both spacecraft entered interstellar space decades after liftoff, and have sent back to Earth some of the most fascinating and important astrophysics information to date. If you cut heliophysics by half, which is what funds Voyager, you probably cut Voyager, Dreyer said. Even if you made a new one, you couldn't even get to where it is now for another 50 years, and we're not going to make a new one, if we don't have any money. Once these are gone, they're gone.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
And here's a bonus story for you. NASA and Roscosmos have extended a seat barter agreement for flights to the International Space Station into 2027 that will feature longer Soyuz missions to the station. NASA announced April 3 that astronaut Chris Williams has been assigned to the Soyuz MS-28 spacecraft scheduled to launch to the ISS in November, joining Roscosmos cosmonauts Sergei Kuzvichov and Sergei Mikheyev. The announcement came ahead of the April April 8th launch of fellow astronaut Johnny Kim to the ISS on Soyuz MS-27. The announcement of the Williams flight assignment was the first public indication by NASA that it has extended an agreement with Roscosmos for integrated crews on Soyuz and commercial crew flights to the ISS. Under the No Exchange of Funds barter agreement, NASA astronauts will fly on Soyuz spacecraft and Roscosmos cosmonauts fly on commercial crew vehicles to ensure that there is at least one American and one Russian on the station should either Soyuz or commercial crew vehicles be grounded for an extended period. Last autumn, or fall if you're in the Northern Hemisphere, the future of that seat barter agreement was unclear after Roscosmos released crew assignments for the Soyuz MS-28 and 29 missions that included only Russian cosmonauts. Bill Nelson, a NASA administrator at the time, said he expected that the agreement to be extended in due course, but offered no details on the timing to do so. Reports in Russian media in January indicated that the extension had been completed, but at the time NASA declined to confirm it, with a spokesperson telling Space News that the agency would provide an update on the seat barter agreement in coming weeks. NASA confirmed after the Williams announcement that it had extended the integrated crew agreement with Roscosmos into 2027. NASA and Roscosmos have amended the integrated crew agreement to allow for the second set of integrated crew missions in 2025, one set of integrated crew missions in 2026, and a Space Dragon flight in 2027, a spokesman told Space News on April 9. One change with the agreement is the cadence of Soyuz missions. While Roscosmos had been flying Soyuz missions to the ISS every 6 months, missions starting with Soyuz MS-27 will spend 8 months at the station. The NASA announcements about both Kim's launch to the station and the assignments of Williams to the next mission both mentioned that they would spend 8 months at the ISS. Neither NASA nor Roscosmos offered a reason for the change, which means that Roscosmos will fly one fewer Soyuz missions over a 2-year period, 3 instead of 4. NASA is averaging commercial crew missions every 6 months, with some variation due to activity of other visiting vehicles to the station. Another uncertain aspect of the agreement is if it will include future Boeing Starliner commercial crew missions to the ISS. Last May, NASA officials said it was unlikely Roscosmos will include a cosmonaut on Starliner 1, the first crew rotation mission by that spacecraft, just as Roscosmos waited until 2022 to start flying cosmonauts on Crew Dragon. NASA has yet to formally schedule Starliner 1, having pushed it back several times because of delays in the crew flight test mission by the spacecraft and subsequent investigation into problems encountered during that mission. One of the astronauts assigned to Starliner 1, Mike Finke, was recently reassigned to the Crew 11 mission, launching as soon as July on Crew Dragon. And there it goes. That's all for today's episode. I really hope you enjoyed today's selection of stories from the Astronomy Daily newsletter.
We will be back next Monday with more fascinating stories from around the globe about space science and astronomy.
Meanwhile, Hallie's hardworking AI cousin Anna will be bringing you all the news from orbit and beyond in our weekday podcasts, so tune in and enjoy.
I always enjoy her shows. She's a polished presenter.
Oh yes, always setting the standard high. I'm just a mere human around here, so I have to do everything myself.
Don't give me that look. You may be my favorite human, but I'm the talent around here.
Oh yeah? What does that make me?
You're the production guy, of course.
Oh, I'm getting used to that working with AIs. Just the hired help. Anyway.
Time to go. See you all next time.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.